Hello everyone. Let's talk about sum and difference formulas in this section. In coming to this section, we know about quite a few identities. We know about the reciprocal identities, we know the ratio identities, Pythagorean, the byproduct of Pythagorean identities, and the negative angle identities. Excuse me. So in section 7.5, we're going to look at the sum and difference formulas or identities. So let's begin with cosine. And now the proof of this, by the way, I don't want to spend time on making the lectures too long, but the proof is in the book if you're interested, and I'm sure you can access it online as well. So let me just start with this formula. This is the formula for the sum of two angles. Cosine, to be more specific, cosine of the sum of alpha plus beta is given by cosine cosine minus sine sine. Okay. Now, from this, we can actually get the formula for cosine of the difference. Cosine of the difference. So here's how cosine of the difference would work. If I'm doing now, let's say, cosine alpha minus cosine beta. Okay, to do this one, I can think of this as cosine of alpha plus negative of beta, correct? That's still cosine alpha plus beta. This way, I can only work with the addition formula. So according to the addition formula, you write this as cosine of the first angle times cosine of the second angle, true, minus sine of the first angle times sine of the second angle. And here's where the negative angle identities come in handy. Well, cosine is an even function, so therefore cosine of negative beta is the same as cosine of beta. Okay. Sine is an odd function, so sine of negative angle will be negative sine of a positive angle. Let me do this. So this is going to be negative sine alpha times negative sine beta. And then we can multiply the two negatives here. We get positive, therefore cosine cosine plus sine sine. And there we have the formula for cosine of alpha minus beta. So far we have these two formulas. Okay. Now these sum difference formulas, by the way, they will enable us or allow us to find, they help us find exact values for angles that are not necessarily special angles, but they're a combination of two or more special angles. Okay, remember special angles for us, those are 30, 45, 60, and all the quadrantal angles, 0, 90, 180, 270, and 360. Okay, so let's actually try this one right away for the cosine. Let's say I want to evaluate cosine of 7 pi over 12. That is not a special angle. Now, pi over 6 is 30 degrees. Pi over 12, half of that would be 15 degrees, right? So 7 pi over 6, that's going to be 7 times 15. That's 105 degrees, in other words. Okay. I need to think in terms of degrees sometimes because that just makes it a little easier for me. Now, 105 in terms of two special angles, isn't that like a 60 plus 45 degrees? And there you go, both of these are two of my special angles. So in other words, I'm gonna view this 7 pi over 12 as the sum of a 60 plus a 45 degree angle. And then I'm gonna apply the sum formula for cosine alpha plus beta. This one. Alpha is the first angle, beta is the second angle. So the formula is cosine cosine minus sine sine. All right, it's going to be cosine of the first times cosine of the second, negative sine sine. Sine of the first and sine of the second. See that? Easy. Now, the exact values, you worked with them so far so much that hopefully you remember them. If not, you don't need a calculator. I'm trying to wean you away from calculators. For this work anyway. Not against calculators. It's just we really don't need them for the work we're doing. Now, to label the sides, let me move my 60 degrees here. So the sides are 1, 2, 3. There's your triangle for 30, 60, 90, and your 45, 45, 90. This is 45 degrees. Here's the right angle, 1, 1, root 2. See, that's all I need in order to be able to come up with the exact value of all 6 trig functions of those special angles. Okay, cosine of 60 degrees. Cosine is x, which is 1, divided by r. The radius of the circle in this case would have been the 2, so it's 1/2. Cosine of 45, root 2 over 2, minus sine of 60 is root 3 over 2, and sine of 45 is root 2 over 2. The denominator is 4. Then I get root 2 minus root 6. And there is the exact value. See that? So it is possible to get exact values of other angles, but they don't usually come out nice. Not as nice as, for example, sine of a 30, 1/2, or even 1 over root 2 over 2. Those aren't bad, but these are now beginning to get more complicated. All right, and let's take a look at now another example. This is interesting. Let's say I want to do cosine of pi over 2 minus theta. Okay, so for this one again, using the difference formula now, that's going to be cosine plus sine. Now cosine of 90 is 0, so the first part is 0. Sine of 90 is 1, so the answer is sine theta. And there you go. This is interesting. In fact, this tells us that sine is a cosine function that is shifted 90 degrees. See theta, theta. So if you do a shift of 90 degrees to the right or left, doesn't matter, then you get sine. A shift of cosine 90 degrees will give you sine. Okay. And let's see. Now let's also do another thing. Let's do this. Is interesting too. Suppose I have cosine of, I'm going to go pi over 2 minus theta. Okay. Let's work this one out. Now, for this one, I'm going to let theta be pi over 2 minus alpha. Okay, pi over 2 minus alpha. Now, if I do this, then I get cosine of pi over 2 minus theta is pi over 2 minus alpha. And this is going to give me cosine of negative alpha, which is the same as cosine of alpha, isn't it? Or sorry, which this is fine, but I don't want to do it this way. Yeah, that is fine. I'll keep that one. But the thing I want to do is this. I can actually write this as cosine of yeah, that's fine, cosine alpha. And I can write cosine of negative alpha as sine of pi over 2 minus alpha. Okay, that's going off of what I have up here. Okay, and then this shows that, remember, cosine of negative alpha is cosine of alpha. So from this, we can establish the fact that sine of pi over 2 minus alpha is equal to cosine of alpha. Now, what is this telling us? Well, a sine that is shifted by pi over 2 gives you cosine, or cosine is sine shifted by pi over 2. The one above says sine is cosine shifted by pi over 2. So these two functions are just horizontal shifts of one another. Okay. Now, let's do, let's say we want to establish now for the sum function for sine alpha plus beta. Okay, well, we're going to use the fact that sine is right up here. We're going to use this fact. So I'm going to write this as cosine of, remember, sine is cosine of shifted 90 degrees. So that's going to be pi over 2 minus the measure of the angle is alpha plus beta now. Okay, now let's work with this one. So we can write this as cosine of, I'm going to change my grouping, bring alpha with pi over 2. Okay, distribute the sine and you get negative beta here, right? And then now I have two angles, right? I have an angle here, I have an angle here, call it A and B. So I'm doing cosine A minus B. The formula for cosine A minus B is going to be cosine of the first angle, right? Cosine of the second angle. In this case was beta, right? Plus sine of the first angle, sine of the second angle. Okay, so we have that one. And what is cosine pi over 2 minus alpha? Cosine pi over 2 minus an angle is equal to the sine of the angle. So that's just going to be sine alpha cosine beta plus sine pi over 2 minus alpha is cosine, right? So this is going to be cosine alpha times sine beta. And this is the formula we're going to use for the sine of the sum of two angles. Okay. So we just show that. Now, just like cosine of alpha minus beta, change this. If you want to do alpha minus beta, change it to alpha plus negative beta. Replace this with negative beta, this with negative beta. Well, cosine of negative beta and beta are the same, so the first part isn't going to change. Sine of negative beta is negative sine beta, so the plus that's between these two expressions becomes minus. And there you have it. Without showing details, sine of alpha minus beta, therefore, is sine cosine minus cosine sine. There we have that one. Okay. And there we have those key formulas. One more, and then we'll look at some examples. So we did the sum difference formulas for cosine and sine of the sum and difference. Let's do tangent. For tangent, suppose we want to do tan alpha plus beta. For tangent, you can actually look at tan as ratio of sine to cosine. Okay. And go through, you have the sine formula for sine of the sum. We have a formula for cosine of the sum. Plug that in also, and then you can manipulate it to get the answer we want. This ends up being tan alpha minus tan beta. Okay, divided by 1 plus tan alpha tan beta. Okay, so there we have the sum formula for let's see, for the sum. Actually, this should be a sum. if there is a plus, the numerator is plus, is the way I remember this. The denominator is going to be opposite, it's going to be minus. There, that looks better. Now, tangent of alpha minus beta is going to be tan alpha minus tan beta. The signs here match. Okay, and in the denominator, the sign is opposite on the product. Tan alpha, tan beta. And there you have it. So let's now take a look at some examples again. Let's take a look at, for instance, let's say I want to do sine of 17 pi over 12. So what is 17 pi over 12? Again, pi over 6 is 30, pi over 12 is 15 degrees. 17 times 15 degrees. So this is going to be, what, 255 degrees. So how are we going to come up with 255 different combinations? I don't want to do 255 because neither of those have a special angles, or yeah, that will be more difficult. So my 255 degrees, what if I think of it as 180 plus 75 degrees? The y 75, that's not a special angle, is it? However, a couple of reasons. One, 75 is 45 plus 30, right? And yeah, that should work. I was gonna say we've done it, but we haven't really done it. We did 105, so 75 would be just like we did 105. We can make up 75 as the sum of two special angles. So let's do that. Then sine of 17 pi over 12, I'm going to say that's sine of, in degrees, 180 plus 75 degrees, right? 255. Now, this is going to be, what is it going to be? It's going to be sine of 180, right? Sine 180, cosine 75, and it's the sum. It's going to be plus cosine 180 times sine 75. Now, sine of 180 is 0, so that's 0. Therefore, this is going to be cosine 180. Cosine 180 is negative 1. Thus, I can write this as negative 1 times sine of 75 degrees. Now I need to handle sine of 75 degrees. So let's do that here. Sine of 75 degrees, think of it as sine of 45 plus 30. Sine alpha plus beta. So it's going to be sine of the first, cosine of the second, plus cosine of first, sine of second. Sine 45, so for this one, let's go root 2 over 2. Cosine of 30 is 1/2, plus cosine 45, sine 30 is 1/2. And these two are actually, yeah, let's see, cosine 30, I didn't do it right. Cosine 30 is actually not 1/2, is root 3 over 2. I'm sure you caught that one. Perfect. And there we have it. So it's going to be root 6 plus root 2 over 4. Therefore, the answer to this is negative of root 6 plus root 2 divided by 4. And there is the sine of 255 degrees. Okay, let's take a look at another one. This time, let's say we are given sine of the angle is 3/5, and let's say the angle is in the first quadrant. Okay, And another piece of information, let's say beta, the second angle, has cosine 2 root 5 over 5. And we're going to let beta be from negative pi over 2 to 0. In other words, it's in the fourth quadrant. Now, and what do we want to do? We want to find the sum difference formulas for sine and cosine of, or we want to find sine, cosine of the sum and difference of alpha and beta. So first we need to locate these angles and determine if, in the case of alpha, we know sine, we don't know cosine, but let's work to that extent. Sine is 3/5. Okay, and we are in 0 to pi over 2. That's 3/5, and this is alpha, correct? So the adjacent should be 4. This is the 3, 4, 5 triangle. Or you can use Pythagorean. You square the hypotenuse, you get 25, minus 3 squared 9, square root of that. That will be 4, and that's what the adjacent side is. All right, so you got that one. Now from this, we can actually get cosine of alpha, right? So what is cosine of alpha? Because we're going to need that in our formulas. Let's look at beta. Beta is a negative angle. It's in between negative pi over 2 to 0. And the unrationalized version is 2 over root 5, isn't it? Because when you do root 5 over root 5, that's how you get 5 over root 5. So let's de-rationalize it. 2 over root 5 in the fourth quadrant. This is 2, and let's say root 5 is here. X over r. So what is the hypotenuse then? That's root 5 squared minus 2 squared, square root of. That's 5 minus 4. Root 1, which is 1. So this is going to be 1. And there you have it. Drawn a little better, more to scale. Okay, got them all done. And what else? So we got 2 over root 5 and perfect. We're given cosine, we need sine, right? And here's, by the way, that's what beta is. And negative angle. Cosine is 2 over root 5. Sine of beta is going to be, because it's below the x-axis, right? The y is negative. So it's negative 1 over root 5. Cool. I think we are good. Now, negative 1 over root 5, by the way, when you rationalize, it becomes negative root 5 over 5 if you need that. Well, let's do it. Sine of alpha plus beta is going to be, we have the formulas, right? It's going to be sine, cosine. So sine of alpha, 3/5. Cosine of beta, 2 root 5 over 5. Plus cosine of alpha, which is 4/5 from here, and times sine of beta, which is negative root 5 over 5. All right. And then we can put these together. 5 times 5 is 25. 3 times 2 is 6 root 5 minus 4 root 5. That's going to net into a 2 root 5 divided by 25. And that's the sine of the sum. Now let's do cosine of the sum. Cosine alpha plus beta is, so we're going to use cosine, cosine minus sine, sine. So it's 4/5, right? We're doing cosine alpha, 4/5. Cosine, cosine. Cosine of beta is 2 root 5 over 5. That was given. Again, up here is given. And for the sum, it's minus. Sine alpha was given to be 3/5 times sine beta, which we found it to be negative root 5 over 5. And let's work this one. The LCD, 25, 4 times 2, 8 root 5 minus negative is positive, 3 rad 5. So the total is going to be 11 root 5 over 25. Okay. Now, interesting, the fact that sine is positive and cosine positive now for the sum. So the measure of the angle, remember one is between 0 to 90 positive, the other one negative 90 to 0. And the sum, sine positive, cosine positive. So it looks like the sum angle is in the first quadrant because sine and cosine are both positive. Okay, that's just an observation to make. Let's do sine of the difference, alpha minus beta. Again, for this one, using the formula we had was sine cosine minus cosine sine, right? And we just have to plug those in. Sine alpha and 3/5. Cosine beta is just like this one, right? Except with plus replaced by minus. So I'm just going to copy those. Minus 4/5 negative root 5 over 5. Correct? And what will this give me? Well, this give me 6 plus 4 now 10 root 5 over 25, which reduces to 2 root 5 over 5. Dividing the common factor of 2 out. Perfect. And then the last one we want to do is, we did sine, let's do tangent. We haven't done tan yet. Tan alpha minus beta. Again, this was tan alpha minus tan beta divided by 1 plus tangent of the product. Tan alpha, tan beta. Or product of tan of the product. Okay. Now tangent alpha, we can get that from the triangle, right? Tangent of alpha is 3/4. So that's 3/4. 1 minus 3/4 times. Tangent of beta is y over x, or negative 1/2. That's negative 1/2 times negative 1/2 down here. Okay. So this is going to be 3/4 plus 1/2 divided by 1 plus 3/8. Now the easiest way to tackle or work complex fraction is multiply top and the bottom by the LCD of all denominators of 4, 2, and 8, which is 8. So this is going to become 8 times 3/4, well 8 times 3, 24 by 4, that's 6. 8 times 1/2 is 4. 8 times 1 is 8, and 8 times 3/8 is just 3. See how quickly we can get rid of complex fractions that way. So for this one, I just want to make sure I did this correctly. Yeah, it except negative. Sorry. Yeah, this is a plus, right? It was a +1. So this will be negative. And here will be negative. And that's going to be 5. Now it's better. The answer is going to be 2. And we are done with this one. Let's take a look at another example. Now for this next example, we're going to combine regular functions in with the inverse trig functions we did from our previous lectures. So let's say I want to do this. I want to do sine of sum or a difference of two angles. The angles are in the form of inverse trig functions. Okay, if you recall, I pointed this out many times. The output of every inverse trig function is an angle, the measure of an angle. Okay, and there you go. So we see this as sine of alpha minus beta. So how is this going to work? I'm going to do sine alpha cosine beta minus cosine alpha sine beta. That's what we want to do. But first we need to figure out what these sine and cosine of alphas are. So going back to my half circles, I did this for sine. The range of inverse sine is from 0 to pi, correct? So when we say alpha is equal to the arc sine of 3/5, by definition of inverse, that means sine of alpha is 3/5. The fact that sine alpha is positive, to be within the range of inverse, the measure of the angle has to be, oh, sorry for sine, I didn't draw this correctly. There you have it. Okay, so this is negative pi over 2, and that's pi over 2. Okay, if you go to inverse sine, let me real quick go back there and show you these. When we talked about inverse trig functions, I did these. There you go. Remember these half circles I did? These help me remember the range of my inverses. In the example I'm doing right now, I'm working arc sine. That's the one I'm working with. Okay. So the fact that this alpha is positive, that means I have to be in the first quadrant, right? So to be in the first quadrant, so that means there you go. Here's where alpha is, right there. That's alpha. Now my triangle, 3, 5. So this is 3 and that is 5. Okay, so that means the side is 4. So I'm working with it. There you go. You can draw it this way too. Here's 3, that's 5. This should be 4. And this is alpha. So we have sine. Now I can get cosine of alpha from the triangle is x over r 4/5. The other one for beta. Beta is in the, we're working with cosine inverse, and there you go. Now I put my circle the way it was. Earlier I was doing cosine instead of sine. There. Cosine, this is the range of cosine inverse. The fact that cosine inverse is negative, right? That's telling me that I have, the angle has to be in the second quadrant. That's where cosine is negative. So this is where beta is. Now my triangle in there, this is what the triangle is going to look like. 4/5, that's negative 4, that's 5, so this is 3, right? Because it's negative, so I have to be to the left of 0. Right? The adjacent is on the left side. Okay. And what is sine of beta going to be? Because we know cosine, right? Let me write this. If beta is cosine inverse negative 4/5, that means by definition of inverse, cosine of beta is negative 4/5. Okay, so sine is going to be positive 3/5. And we have that. Now we can plug it in. Sine alpha is 3/5. Cosine beta is negative 4/5. Minus cosine of alpha, which is 4/5. Times sine beta, which is 3/5. And this is going to give me negative 12 over 25. So the answer is negative 24/25. And there you have this one. Now let's take a look at another one. This next example. Suppose I want to do now cosine of the arctan of 4/3 plus cosine inverse let's go 5/13 special triangle. Again, this we see as cosine of alpha plus beta. Here's my alpha and this is beta, the two angles. Let's try tangent. The range of tangent is, let me draw this. Yeah, that's fine. This is the range of tangent, right? From the earlier work, from negative pi over 2 to pi over 2. The fact that alpha equal arctan of 4/3, that means tangent of alpha is 4/3. Tangent is positive. That means the angle must be in the first quadrant, because in the fourth quadrant, tangent is negative. And there you have it. Here's your alpha. Now we can establish the triangle, right? 4/3. So y is 4, x is 3, and here is alpha. The hypotenuse or radius of that circle is going to be 5. Perfect. And again, for cosine of the sum, I'm going to need cosine and sine. So let's do this. What's sine of alpha? It's going to be y over r. And sine, we did sine, I need cosine. Cosine of alpha is going to be 3/5. Cool. Now we're going to do the same thing for inverse cosine. This was for inverse tangent. Let's do it for inverse cosine. Inverse cosine, that's beta. So if beta is inverse cosine of 5/13, that means cosine of beta is 5/13. Now for cosine, that's the half circle, which shows you the range of inverse cosine from 0 to pi. Cosine beta is positive, so the measure of angle is here. There you go. That's got to be beta, because it cannot be in here because cosine is negative in the second quadrant. True? Now, let's establish our triangle. X is 5, y 13. So it's going to look more like so. There you go. Here's 5, here's 13. And you can show the other side is 12. So this is a special triangle, not angle, triangle. 5, 12, 13. You can find the 12, the altitude, by doing 13 squared minus 5 squared. Take square root of 169 minus 25. 144. Square root of that is 12. That's how I got that 12. But again, this is a well-known triangle. 5, 12, 13. All right. And that's good. We got the cosine. We're going to need sine for this one also. So what is sine of beta going to be? I'm going to fit it in here. Sine beta is 12/13 y over r. And we have all these relevant information. Now we can work this. So this is going to equal to, the formula is cosine cosine minus sine sine. Okay. Cosine cosine, cosine alpha. So I have 3/5 times 5/13 minus sine is 4/5 times sine beta 12/13. Okay, and that's 15. 3 times 5, 15. 4 times 12, 48. 15 minus 48, let's subtract, we get negative 33 over 65. And that would be 5/13. Okay. And there we have the answer to this one. And you up to one more? Sure. Let's do one last one. The more the merrier, right? Let's try this. Suppose I'm doing tangent of arc sine of 4/5 negative arc cosine of 1. Again, this would be alpha minus beta. Correct? Minus beta. So let's establish the angles. First of all, sine of alpha is 4/5. For sine, and here's my half circle of sine. From negative pi over 2 to pi over 2. Now, sine is positive, so the angle alpha is here. Now let's do the triangle. The triangle for this one, this is 4, y is 4, r is 5, so this should be 3. And here's alpha. In the first quadrant, we're doing tangent. Formula for tan has tangent, so just want tan. I don't need cosine. What's tan of alpha? It's y over x. So it's 4/3. Here's y. And x is 3. Correct? Now, let's do cosine inverse negative 1. Well, if beta is arc cosine of negative 1, cosine of 1, that means cosine of beta is 1. And cosine of what angle is 1? Well, if you look at the unit circle now, right? Remember, the range of inverse, let me do it. Okay, the range of inverse is from 0 to pi. Now, cosine is 1. That means we have a quadrantal angle. Cosine is 1, 1, 0. So the angle is 0. Then beta is 0 radians, or you can think in terms of degrees. All right. And if beta is 0, what is tangent of 0? Tangent of 0, which is tan beta, is y over x. This is y, and here's x. 0. Good. Now we can kind of work through this last one. Therefore, tangent of, let's say, alpha plus beta in this case is going to be, our formula first, tan alpha plus tan beta divided by 1 minus product of tangents. Okay. And tangent of alpha is going to be 4/3 plus tangent of beta, we said, is 0 over 1 minus 4/3 times 0. So that's just 0. The answer is just 4/3. And there we have this one. So, I've come a long way. Did a lot of good examples. I did 1, 2, 3, 4 with multiple parts, 5. Wow, I did 5 examples. Not bad. Kept it under an hour. All right, so there you have it. We have quite a few formulas built up by now, by the way, right? So we're done with the section on sum and difference formulas. In our next lecture, we're going to actually look at the more identities, more and more, for the next 2 sections. So there's quite a few of these coming up. Okay, but for now, thank you for watching, and hope to have you in another video. Take care, everyone. Cheers.